This is day 20 of solving math problems until a Hololive member notices me. So here we have a integral, and it seems like a very scary integral at first, right? Because of the x to the 4 in the denominator inside the square root raised to the power of 5. But let me tell you that it's not as hard as it seems. Okay? What we will do, right, is pretty much rewrite our integral as the integral of x divided by the square root of 1 plus 4x squared plus x squared squared raised to the 5 dx. And we're going to have u be equal to x squared, and the derivative is 2x dx, and so for dx we get dx equal to du over 2x, and so we have an x in the top. This will simply just become the integral, or basically 1/2 times the integral of 1 divided by the square root of 1 plus 4u plus u squared raised to the 5 du. Okay, so let's just go ahead and remember that u is equal to x squared. So we'll write that up here. Equals x squared. Now what we will do, right, is complete the square for the denominator. So we have u squared plus 4u plus 1. If we add 3 and subtract 3, we will have u plus 2 squared minus 3. Okay, so we can rewrite this as 1/2 times the integral of 1 divided by the square root of u plus 2 squared minus 3 raised to the 5. Okay, and here we're going to use a, not dx, apologies, u. So what we're going to do, right, is pretty much make a quick substitution again, and it's not really going to change anything. It's just going to replace u plus 2 with v, so v equals u plus 2. So we have 1/2 times the integral of 1 divided by the square root of v squared minus 3 to the power of 5 dv. Okay, so we're making some good progress. Okay, we're making some fairly decent progress. And the main problem is, which trig sub do we use? Well, let's go ahead and check. So we start off with sine squared theta plus cosine squared theta is equal to 1. What we're going to do, right, is we're going to check what we could divide by. So we're going to divide by, let's see, cosine, so we will get secant squared, or secant, yeah, squared theta is equal to, and then sine divided by cosine, that is tan squared theta, and then plus 1. And we're going to subtract 1, so pretty much our substitution is going to be secant. So pretty much v is going to be equal to the square root of 3 secant theta. dv is equal to root 3 secant theta tan theta d theta. Okay, so pretty much we will have root 3 over 2. times the integral of secant theta tan theta d theta. And the bottom, pretty much we will have, let's just simplify that. So we have 3, right? So pretty much root 3 to the 5 times secant squared theta minus 1, which becomes tangent squared, and then which becomes just tangent. And it's raised to the 5, so it's tan 5 theta. So we pretty much are going to have root 3 to the 5, which is 243. And this will be tan to the 5 theta. And we're going to bring this out to the front, which will be 2 root 243, which will just be 1 over 18. And after this, we will have the tangent cancel in the numerator, so we will have 1 over 18, the integral of secant theta tan 5 or 4 theta d theta. Okay, so let's just say v is equal to root 3 secant theta. Okay, so it's always good to keep track of our substitutions. And now the main problem is, what substitution do we use here? So probably write this in terms of cotangent. So we have 1 over 18 times the integral of secant theta cotangent 4 theta d theta, which pretty much here we could use by parts, but I'm not really going to do that. So what we're going to do, right, is we're going to use the fact that we have cotangent is cosine 4 theta, and then divide that by sine 4 theta, right? And the cosine and secant are going to cancel each other out, which will just simply leave cosine cubed sine cubed of theta. And here, right, what we're going to pretty much do is we're going to use trig identities. So we have 1 over 18 times the integral of 1 minus sine squared theta times cosine theta all over sine to the 4 theta d theta, right? And what we're going to do is pretty much make a strange substitution, right? And let's just go ahead and simplify this a bit, right? We have okay. So I'm going to write this using trig identity. So we have 1 over 18 times the integral of cosine theta times 1 minus sine squared theta over sine to the 4 theta d theta. And here I'm going to make a new substitution again, where w is equal to sine theta. And dw is equal to cosine theta d theta. And so we have cosine theta d theta, we could just rewrite this as 1 over 18 times the integral of 1 minus w squared divided by w to the 4 dw. And now what we're going to do is pretty much just do long division. So we have 1 over 18 times the integral of 1 over w to the 4 minus 1 over w squared dw. Okay? Which will give us 1 over 18 times, not the integral, times negative 1 over 3w cubed plus 1 over w plus c. So now working backwards, we're going to undo our substitutions. So w cubed is sine cubed of 1 over 18 times 1 over sine, which is going to be cosecant theta, minus 1/3 cosecant cubed theta plus c. And then we know that secant is root or v over root 3. And using the right triangle that we have theta, and we have root 3 v, and this is going to be v squared minus 3. And finding cosecant theta, that is going to be equal to v over root v squared minus 3. So we have 1 over 18 times v over root v squared minus 3 minus 1 over 3, and then multiply by v over the square root of v squared minus 3 cubed plus c. And since we know that v is u plus 2 and u is x squared, we can rewrite finally our integral as giving us x squared plus 2 over the square root of x squared plus 2 squared minus 3 minus 1 over 3 times x squared plus 2 over the square root of x squared plus 2 squared minus 3 cubed plus c. So, as you can see, this is quite a interesting integral. It's not all too hard, but you do need a lot of substitutions, and you have to undo all those substitutions, which might make it hard, but it's worth it. Everything works out perfectly fine. So, yeah. Thank you for watching, and bye-bye.